Physicists thus confirm the upper limit for the speed of sound in the universe. Einstein's theories of special relativity gave us the speed limit of the universe, the light and vacuum, but the absolute top speed of sound for any medium is somewhat trickier to constrain. It's impossible to measure the speed of every single material in existence, but scientists have found out to have now managed to pin down the upper limit based upon fundamental constraints, the universal parameters which we understand the physics of the universe. The speed limit according to new calculations is 32 kilometers per second, 22 miles you know, per second. That's about twice the speed of sound traveling through diamond. Both sound and light waves behave differently. Visible light is a form of electromagnetic radiation named light waves consist of oscillating electric and magnetic fields. These fields generate a self-perpetuating electromagnetic wave that can travel in a vacuum. Its top speed is around 300,000 kilometers per second. Traveling through a medium like water or an atmosphere slows it down. Sounds like a mechanical wave, which is caused by a vibration in a medium. As the wave travels through the medium, that medium's molecules collide with each other, transferring energy as it goes. Hence, the more rigid the medium, the more difficult it is to compress faster sound levels. For example, water has more tightly packed particles than air, which is partially why whales can communicate through such distances in the ocean. In a rigid solid, like a diamond, sound can travel much faster. This can reverse the properties studied inside the Earth when sound craves or earthquakes travel through it. We can understand the interiors of stars. Sound waves and solids are hugely important across many scientific fields. For example, science meteorologists use sound waves initiated by earthquakes deep into Earth to understand the nature of seismic events and properties of Earth composition. They're also interesting to material scientists because the sound waves are related to important elastic properties and the ability to resist stress. Now you can see what the problem with constraining the speed of sound. Now we account for all possible materials in the universe, the upper velocity of sound. If followable constraints are useful, to calculate the rate of sound, the team of scientists at the Queen Mary University of London, Cambridge in the UK, Institute of High Pressure Physics in Russia found the speed limit depends on two fundamental constraints. These are fine structure constraint, which characterizes the strength of electromagnetic interaction between elementary charged particles, and the proton mass intro. So, yep, that means the speed. And yes, so where was I again? Oh, I was around here. So, yeah, we can show a simple combination that can basically, have some dimensions that have unexpected and specific there. And yeah, that's how Faraday tune provides structure between electron mass ratio, and that's how the balance provides the habitable zone where life animals can emerge. And yes, it contains phases with speed, which waves travel to solids to liquid, the speed of sound. In order to confirm the equation, the team experimentally measured a speed of a large number of elemental solids and liquids, which returned the results consistent with the predictions. So the scientific theory that yes, the speed of sound should decrease with the mass of the atom. And according to the prediction, sound should move fastest towards solid atomic hydrogen, which can only exist at extremely high pressures, above 1 billion times Earth's sea level pressure. Obtaining that sample to verify it is going to be very hard, so we rely on calculations to do it, which will be between 250 and 1,000 gigapascals. And that, again, the results are only agreed with their predictions. So applying the team's equation remains consistent. It could prove to be a valuable tool and understanding the broader, not for understanding individual materials, but the broader universe that we live in. So we have to believe these findings of the study could further scientific applications by understanding the limits of properties such as viscosity and thermal conductivity for relative or high temperature fluid conductivity, quick gone plasma, and even black hole physics. And there we go. That's here. We have finally discovered the limit of the sound, and yeah, of course, there could be unknown materials that could transfer the probably materials that we don't know of yet. But out of all the existing materials that we have discovered, we have found the limit of speed of sound. So that means Sonic is also not the limit of speed of sound. I'm sorry, Sonic. You'll be something else some other day. So that's basically it about this video. Goodbye.